Okay, in this lecture, we're just going to talk about the scientific method and how an experiment is set up. This should be, for all practical purposes, review of almost every science class that you've ever taken. So this will be kind of brief and to the point, with a couple of assignments that you will see in your OneNote that you will complete. So the process, of course, of the scientific method is a logical kind of step-by-step process that all scientists are going to be using to obtain information. One of the labs that you'll be able to do on your own will illustrate, of course, the scientific method. The steps that we're going to look at here are we're going to look at observation and inferences, which we talked about earlier, the difference between those two things. Creation of a hypothesis, the actual experiment itself and the components that it contains, data that is collected, and of course coming up with some kind of an analysis or conclusion at the end. So here's, as an example, a situation that we're going to use in this lecture to illustrate these different components of the scientific method. In this situation, John Smith has been hired by the city of Virginia Beach to investigate the recent attacks off the resort's coast. He has a budget of $40,000, a 25-foot boat, and 3 graduate student assistants to help him. A local helicopter has also been donated by a local television station, should he need one. So this is our problem. And now we need to go about using the scientific method to investigate why they seem to have shark attacks happening. So the hypothesis, as earlier discussed here, is simply that educated guess or prediction about the relationship between two variables, basically. It is that explanation. It can be confused with an inference, but to identify a hypothesis correctly, as you should have noted in the one worksheet, there was no hypotheses. Nobody had the hypothesis proposed because you must see the if and then within the hypothesis statement. If this happens, then this will happen. It has to be of that nature so that it can be tested. Okay, so in a example, if you want to take the time, and you can type this off to the side of this slide about the situation, come up with possible 2 hypotheses for the shark attack scenario. So one that I came up with, if that there are more humans swimming in the ocean, then there will be more shark attacks. Once again, you have that if, then statement. That's the only way you can identify a hypothesis. We need to look at when we're testing things, what we are referring to as the independent variable. The independent variable is sometimes referred to as the manipulated variable. It's the variable that actually is changed by the scientist running the experiment. It's what I do to make things different. So if I'm testing humans and shark in the water and the number of shark attacks, I can manipulate the number of humans that I put in the water and see how many of them lose a leg or whatever, based upon being chomped up by a shark. I have the control. That's what an independent variable is. Probably the hardest thing for many students to identify, even at this stage of the game of your educational career, and probably having been talked about over and over again in every science class that you've ever taken. I still find that the independent variable is the most easily confused. So what I would say I can control is how many people I put out there into the water and see what happens to them. The dependent variable is actually the easiest variable, I think, to identify in an experimental situation. Because it's referred to as the responding variable, but basically what it is, it's the data that you actually collect, the results. So if I put people in the water and I want to see if more people get attacked, I'm just counting. I can easily count how many people get bitten by a shark. That's an easy way to do that. It's a very, very objective bit of information. And I always remember dependent and data, DD, and that's the easy way to think of that. So I could just simply count how many people get attacked. A control group is also important because it's a comparison group. So in this group, you're not doing anything to them. They lack the independent variable. They're identical, but they don't have the identical, the independent variable. So I could look at a beach with no people in it or fewer people and then measure how many shark attacks they are versus a beach that I put 1,000 people on and see how many shark attacks occurred, because I can control the number of people. And again, it's just a comparison because we want to see if that independent variable actually had the effect that the hypothesis was predicting. In your experimental group, this is the group that has the independent variable. Both groups, you measure data, so they both contain the dependent variable. And this could be number of people. I could say it was the place where the sharks attacked. It's whatever I define the independent variable as. Usually your hypothesis gives you a clue as to what the independent variable is going to be. If this happens, then this will occur. So if there are 10 people in the ocean, then I will see fewer shark attacks. Or if there are 1,000 people swimming, then I will see more shark attacks. It's the number of people that I can actually manipulate. Think of the independent variable as something you can actually touch. You have control over it. Controlled variables would be things that are constant between groups. They have to remain the same because the only difference between an experimental group and a control group would be the independent variable. Everything else should remain the same. You have to have identical values because you don't want to have a difference that you didn't account for between an experimental group and a control group that could have influenced your data. You really want to say that your data was due to this manipulated or independent variable. So data comes in two forms. One is a quantitative, which is actual measurements, counting, something that people can't argue with you about, versus a qualitative, which is more descriptive. And that usually leads to different scientists can argue amongst themselves that your data wasn't very good. If necessary, it's just a counting number, something that gives you a very, very precise measurement versus a subjective measure like a response on a survey. How do you feel about coming back to school on the 21st? Well, some people could say, it's okay, I'm okay, or I feel really bad. Well, what does that really mean? Versus on a scale of 1 to 10, with 10 being the worst and 1 being the best, how would you rank your feelings? That gives you a little more quantitative data in that sense. So examples would be the number of people, number of shark attacks, etc., versus the type of attack. Was it a brush by? Was it actually the attack was because they bit your foot off or something like that? And finally, the data should tell you something. It should give you some kind of explanation. It should either prove or disprove your hypothesis. It should, point you in directions for further research, something of that nature. How many times should you run an experiment? More is better than few. The exact number of experimental repetitions varies depending upon what you're testing. But generally, most repetitions or trials, as they're referred to sometimes, usually about 10, unless it's a drug manufacturing, then it can be into the thousands. So we're testing vaccines for COVID. I'm worried that we're not going to have enough trials before they say we're going to release a vaccine to the general public. because we want to make sure the vaccine works and it doesn't cause harm. And that usually takes time. And time, is kind of critical right now when we're dealing with this pandemic in our society. So variables, just by definition, you can have, these are just things that can change in an experiment. You usually have three types. The independent is the one that you manipulate. The dependent, of course, is the data that you measure. And all the other variables, should be matched. So controlled variables are the matched variables. That means they would be identical between two groups. So that's a real quick overview of the scientific method and an experimental design. Just to get you to think about it a little bit, as you probably saw in the practice test or pre-test that you took. There are two assignments in your OneNote that you will need to complete. One is a very simple one that I actually used to give to my 7th graders when I taught 7th grade, is using the Simpson characters and scenarios. Can you identify the different components in an experimental design? So for each of these scenarios, you will simply type down here on your OneNote page what you would identify based upon this scenario and this example with Smithers. What would be called the control group, what would be the experimental group, what would be the independent and dependent variables, and what's a possible hypothesis for this particular scenario. That's up for you to decide. So again, on OneNote, you're simply going to type onto the OneNote page, and then when you're finished, you will, unfortunately, I didn't change this in the snip that I did, and I'll change it when you get it in your OneNote. You'll submit the Summit checkpoint for this. But in order to submit the Summit checkpoint, you actually have to do both of these assignments. They're both of the variable worksheets are part of the checkpoint. So this second one is more of a CP Bio worksheet. It's a little more complicated, a little harder than the first one. The first one's just kind of get you in the mindset, and then you can move on to the one that really counts, is this worksheet that's called Identification of Variables. Again, you will do all of this on your OneNote page. And again, when you finish, I'll have the correct instructions in your OneNote that says that you will submit these as a checkpoint. You have to have both done to submit the checkpoint, not just one versus the other. So the instructions will say that with that. So with that in mind, you can go ahead and get working on this. I will post in the answer key some of the answers. So look for the answer key if you want to check this later. But again, as you could probably tell on pre-test that you took, I do ask you questions about certain scenarios. Can you identify variables? Can you predict a hypothesis? And that sort of thing. Okay, so with that in mind, you can go ahead and get busy. Good luck.